Let's have a look at an example question of using a two-way table to calculate probabilities. So a two-way table is a different way of representing information similar to a Venn diagram, but it can represent more information because we don't have to just have two or three circles overlapping, and it's clearer for when we have more variables. So this two-way table tells us about how 100 children traveled to school one day. The options that we've recorded are walk, car, or other, and then the children are split into boys and girls. The first part of our question asks us to complete the two-way table. Now, to complete a two-way table, you need to choose a column or a row that has all of the pieces of information except for one. So if we have a look at children who walk to school first, we have a look at this column. We know that there were 15 boys walking to school. We know that there were 37 children walking to school in total. So if there were 37 children walking to school and 15 of them were boys, 37 take away 15 gives us 22. The other 22 children must have been girls walking to school. So we chose a column that had only one empty space. If we tried to choose to fill in the car column, we'd get stuck because we have two unknown spaces there, two unknown values. So that's not a good one to choose next. Let's have a look at the other column. 14 boys walk to school and 16 girls walk to school. So if we want to know the total number of students that walk to school, we do 14 plus 16, and that gives us 30. 30 students walk to school altogether. We could fill in more information about the boys in this row here because we know how many boys walked, how many boys took another form of transport, and the total number of boys that travelled to school. So if we have 54 boys, we take away the 14 who had some other way of getting to school, and we take away the 15 who walked to school, we are left with 25 students, and they must have travelled by car. And once again, we chose a row that only had one empty space. And now we can fill in the car column because we know 25 boys travelled to school using a car, plus the 8 girls who travelled, and that gives us 33 students when we add them together in total who travelled by car. And we just have one remaining square here, and we can choose which way to calculate. We can calculate it from the totals column, or we could calculate it from the girls row, because there's only one spot missing in each of those, and we'll get the same value whichever one we choose. Let's choose the totals column because it's only got 3 values, so it's a bit easier. So altogether, there are 100 children, 54 boys total. And so if we do 100 and we take away the 54 boys, we are left with 46 female students or 46 girls. And so we filled in the entire two-way table. And when we add together each column, we should get the totals in the bottom of the column down here. And when we add together each row, we should get the totals over here. 15 boys walking, 25 boys by car, and 14 other gives us 54. And the same when we add up all the girls and their modes of transport, we should get 46. Now that our two-way table is complete, let's look at some probability calculations. Part B says, what is the probability that a randomly selected student or child was a boy who walked to school? Let's have a look at our two-way table. We'll locate the boys row and the walking column. And where those two intersect, the boys row and the walking column, is this 15 value here. There were 15 boys who walked to school. So the probability of randomly selecting a boy who walked to school is 15 out of the total number of students, which is 100. 15 out of 100. That's the probability of randomly selecting a boy who walked to school. And we can simplify this fraction to 3 over 10. Part C says, what is the probability that a randomly selected student travelled to school some other way? So we need to know how many students travelled some other way out of the total number of students. Well, there were 14 boys and 16 girls who travelled some other way, but altogether 30 students travelled to school some other way that wasn't walking or a car. So the probability we randomly select a student who travelled to school some other way is 30 out of, or divided by, the total number of students, which is 100. 30 out of the 100 students travelled to school some other way that wasn't walking or cars. And once again, we can simplify that to 3 out of 10. Our last question says, what is the probability that a randomly selected student was a girl? So we need to look at our two-way table and figure out how many girls there were altogether. 22 walked 8 went in a car, and 16 girls traveled some other way. So altogether, we have 46 girls when we add all those numbers in that row. All the numbers in the girls row, we get 46 girls. So the probability that a randomly selected student was a girl is 46 out of 100. And once again, we can simplify that to 23 out of